Greetings everyone, in today's video we'll show you how to create Raindrops Shader Graph in Unity. We will use in this video the universal rendering pipeline. This also applies for the HDRP if you want. You will learn also how to create the textures of the raindrops in Photoshop, so that's also included. I give all the credits to Polytoots who did this shader using Amplify shader editor, so it's worth to mention that he did this before me, and I'll provide his original video link down in the description. Let's get started. To start by creating the raindrops texture in Photoshop, so create a new document with 512 for the width and height. Make sure it's RGB color. Fill the background with black color, then create a new layer, and simply we draw a circle. Then we use the gradient fill tool to fill a rectangle starting from the middle of this circle upwards. The gradient, of course, will start from white with full transparency, then to zero transparency at the end. Duplicate that raindrop and scatter it around the texture. Change the size, some tall, some wide, and scatter them to fill the texture. Then use the crop tool to make sure there is no extra tails invisible outside the borders of the texture. Then we use the offset filter to offset the texture down a bit using an offset of 265. Then we fill this black area with some more raindrops to avoid cutting the raindrops while scrolling down, so we can get a seamless, endless texture. Then merge all the raindrops into one layer. Then let's create a new texture. We want to copy all the channels into one channel, which is the red channel. So after creating the new texture, fill it with black. Then go back to the texture and copy the raindrops layer into the red channel of the new texture. You'll see now we have only on the red channel the texture we created, because we will use that channel in the shader graph. Additionally, we will create a new layer with a gradient mask, because we want the rain to be visible at the top, then invisible at the bottom. So let's use the gradient fill to fill the texture from the left to right with white with full transparency into zero transparency on the right. Then copy this new mask into the green channel on the new texture. You'll get something like this as a final result. And now we are ready to export this texture as PNG to use it in Unity. Now let's create a new Unity project using the universal render pipeline and name it Raindrops Shader Graph. Let's remove the workbench which comes with the default scene for URP. Then create a new box and sphere which we will use to show the shader results on them. And I chose a box and sphere so we can see the results on multiple surfaces, so we can detect also the bugs or how it looks on different shapes. So let's now create a new PBR shader. Let's name it Raindrops Shader Graph. And we need also to create a new material to hold this shader. So create also a new material, Raindrops material, then drag and drop the shader onto the material. So we applied the shader on it. Now let's open the shader graph and start adding some nodes. Let's first create a prototype to show the concept, since the majority will think it's an easy shader graph with just a scrolling shader on the surface. So let's do that and see what will happen and what issues we will face. So start by adding a sample texture 2D, then add to it the texture we created in Photoshop. Then simply you will think we need a time node and a vector 2 to control on which direction we will scroll the texture, and of course a tiling and offset node. Let's do those. Multiply the time with the speed you want, then link the result of multiplying into the tiling. Create vector 2, but we want to control the Y speed only because the rain always falls from top to down. Link the tiling and offset to the UV of the texture, save the shader, and let's see what we'll get. Use the results of the red channel only and link that to the albedo on the material so we can see the results clearly when we click play. At the beginning you might think, yes, we did it and it's easy shader graph, but the truth is, as you can see, the texture is moving in different directions based on the orientation of the game object. So if I rotate the cube, the rain could fly up instead of falling down, and also on some edges it's up or right or left depending on the UV of the game object we're rotating. To solve those, let's do the following. We want the rain to always drop down and we want it only on the edges of the game object, not on the top of it. So we don't need to see a texture on the top of the object. So we can start by world position node to get the position of the world rather than the game object itself. And since we will use the raindrop texture much, let's create it as a property, then link it to the sample texture 2D. Then create a position and use the world, not the game object, as a start point. We split the world position and we get the X and Y axes by using the red and green channels. And why we're doing that? Because in the world, the X and Y axes represents the front and back edges of the cube or the game object. So we combine the X and the Y axes, then we use the tiling and offset by linking the results of combining to the offset. Then, as we did before, we use the time and multiply node to control the speed of the raindrops, since we will only scroll on the y-axis, and we link the results into the offset. Then link the results to the UV of the sample texture 2D. Hit play, and now we will see the raindrops falling correctly on the front and the back edges of the cube, regardless the rotation of the cube, because now it's related to the world position rather than the game object position. Now we can repeat the process we did, but this time for the Z and Y axes, which represents the right and left sides of the cube or the game object. So the only difference here, we link the y-axis to the x-axis when we combine, and we link the z-axis to the y-axis. The rest of the steps are the same here, so I'll fast forward a bit. In the end, we combine the results using an add node, so we link the red channel from the top sample texture 2D with the bottom one. Then we link them to the albedo for now. Let's see what we got as a result. As we can see now, the raindrops falls perfectly on the edges on the front, back, and right and left, but there are some overlapping of the textures. To solve this, we need to create some masks. Let's first combine all the nodes created into one group called raindrops. Let's start by the world normal vector, since we created the surfaces using the world position. Then we link it to the absolute node, so we can only get positive values for the normals and discarding the negative ones. Then we deduct from the value of the normal, which is 1, 0.5. This way we can see clearly each edges of the game object. So in the center you can see the blue channel, which represents the front and back faces, while the red channel represents the right and left. The green channel represents the top and the bottom of the game object. Then we use the split node to gain access to each channel separately. Let's group everything related to the mask into a mask group. So for the front and back textures, we will use the lerp node to lerp smoothly between the 0 value, which means total invisibility, into the value of the blue channel mask, so we can see only when the game object facing front of the world. So use a lerp map to lerp between 0 and the blue channel mask for the front and back textures. We do the same for the right and the left sides by using a lerp node to lerp between 0 value and the red channel mask, which represent the right and left sides. After that, we add the results together using an add node. Then we saturate the results, because if we didn't saturate, we will get values above the 1 and below the 0, while we need only values between 0 and 1 for the textures. And now if we click play, we can see the raindrops falling perfectly on all the edges of the cube, except the top one. And why we did that? Because it's unrealistic to show raindrops sliding on the top of the surface, while instead of that there should be splotches. But before we add the splotches, we need to add distortions to the falling raindrops, because it seems unrealistic that they fall straight away down. Also, before we proceeding, if you want to have control regarding the tiling of the raindrop texture, you can add a vector too, name it rain texture tiling, so you can control how much repeated is the rain texture over the game object. Now to create the distortion effect, we can start using the gradient noise, then create a new property, it's a vector 1, and name it the distortion scale, so you can control the scale of the noise you want. After that, we can create a normal from height node, so we create a normal map using the gradient noise we're using. And to have control over the trends of the normal map we are creating, we can use a multiply node and a new property called the normal power. Multiply both of them, then link the results to the normal from height. So we can have now control over the normal map we created and how strong the raindrops will appear on the texture. And to apply this effect, we use an add node before the tiling and offset for both the right, left, and front, back surfaces. So just use an add node, link the result of the distortion to it, and link the results of the combine to it too. Then link the outcome to the UV of the tiling and offset node. Save, and now we can see the distortion has been applied to the raindrops textures. But that distortion is not applied the same way to all game objects, because they are different shapes. So it might work for the sphere but not work perfectly for the cube. So let's create a material for each one for the cube and another material for the sphere, so we can adjust the distortion for each one separately. and perfectly. Apply the new material to the sphere and the cube, adjust the noise till you are happy with the results, and as you can see now, the raindrops feels more realistic. I think now we reached a good results to start seeing the raindrops as they should be by moving from the preview of the albedo to linking the results into the smoothness and the normal. So let's convert the results into a normal map by creating a normal from height node and link the results to it. So link the results of the normal to the normal on the master node and link the results before multiplying with the normal to the smoothness, which highlights the raindrops. Save, hit play, and now we started to see the raindrops as they should be seen on a game object. To control the normal of the raindrops, we can create a new property, name it normal power. Then we multiply it with the results before multiplying it with the height from normal. This way you can control how visible the raindrops is on the surface. And of course, all game objects should have textures. So to control that, let's create a new property and name it the main texture, and create a new sample texture 2D node and link the results to the albedo. Then we can apply a texture for both the cube and the sphere. Now let's create the splotches, which will appear only on the top side of the game objects. We can start by creating a Voronoi node. To control the density of the Voronoi, we can create a new property and name it splotches density and link it then to the cell density of the Voronoi node. Then we want to move the Voronoi node over time, so we can use time node and multiply it with a new property. It's a vector one called splotches spasm, and we link the results to the angle offset. To start seeing the splotches, we use a step node with the value of the input 0.2. That means we will show a white dots when the alpha is higher than 0.2. And we create another step node with less value 0.1 to show a white tiny dots. And to make the upper step node fades away over time, we multiply the results of the step node with the cells. That will give that nice fading effect. Then we link the results to the tiling and offset on the UV. Then we create sample texture 2D with the raindrops texture and link the results to the UV. You'll see now a green texture with flickering red dots. Those flickering red dots will represent the splotches that happens when rain falls on a surface. So we use a multiply node to multiply the red channel to see those red flickers, but with the small step node which we used previously to show those nice flickering white dots that happen when rain falls on the ground in real life. To control the strength of the splotches, we can create a new property and name it splotches power and multiply it with the final result. We want the splotches to show on the top of the game object and down to the side surfaces, but not at the bottom of it. So we can split the normal world vector and get the Y channel of it We add that to the 0.1 we created to allow seeing the splotches from top to the bottom of the game object, but we stop before the bottom a bit. As you can see now, when we add the 0.5 to the Y channel, we can see a white gradient from the top and ends before the bottom of the game object. We multiply that with the final result of the splotches, so the splotches will see perfectly as planned. Let's group all the nodes related to the splotches into one group so we keep things organized. Then we use an add node to add the results of the splotches to the raindrops. The value of the smoothness is always something above 1, so we add another add node and we use a new property called a smoothness control, and we set it as a slider between 0 and 1. Then we link the results to the smoothness. Let's now save the shader graph, return back to the game objects, add a texture to the cube and the sphere, and see the results we have created. As you can see now, on the top surface of the cube we can see the splotches, we can control their density and power, and everything working perfectly as expected. When we rotate the cube, the raindrops keeps falling from top to down regardless the rotation of the cube, and on the top we see the splotches. Also on the sides we can see splotches, but not at the bottom of the game object, which is perfect. And that's it for today's video. I hope you enjoyed watching. If you have any questions, don't hesitate to join our Discord server to ask me there. Also, if you found this useful, don't forget to hit like, share, and the notification bell so you don't miss the next video. Thanks to our awesome supporters on Patreon: Dimitri Drekchik, Sepsep, Christopher Mansey, Bing Fi Han Chong, Biller Christopher, Jamie CS, Claudio A, Leave, Da Manio Chirenzi, Norbert Gorful, Andres Philip, Ether the Skylord, Panda Owl, Brian Fonman, Zen Yang, Chen Ran Ning, Sky Rolnik, Jos Enrique, Mohamed Aydem, Pira Chambunchim, Fu R, T.S. Shaharbar, Dimitri Vasiliev, Breadman, Joshua Kratoshville, Parker Nilsson, Giacomo Mariani, Jasle Fever, Jens Valentine, and Jack Crystal. By becoming a Patreon, you can download all our projects. Till next time, see you soon.